This is 2018. I've skipped 2019 because the question there, these papers were set by the same person. So he was bringing back his questions. So we can do one question. So from question 1, A, the sets A, B, C all intersect, and U is a union, is an inverse set. Shade the part described by the set. So shade, I'll ask everyone to be muted. This is fuzzy. So shade B complement union A complement intersection C. Complement in a Venn diagram. Given that A, B, C all intersect, so you're given to shade. So what you do is, I know most of us like simplifying first, which is a good thing also. So you first take the complement which is outside, take it inside. You're going to have B, complement, so it's just B. Union will become intersection. And then that complement, as it is coming inside, it will give us, or we can keep it outside first to avoid confusions. It will stick there. Then I'll go for it. B intersection A union C. What an easy set to shade. A, B, C. Inverse A, B, C. A union C, intersection B. So as you go to A union C, you can even avoid wasting time. To A union C, you're looking for what is in B. A union C, it's here, but you just want that thing which is also in B. But it is in C, it is in A. That's all. That's intersection. Hello?
Is the simplification okay?
Is the simplification okay?
Yes, sir.
So explain again.
First, the question of simplification, it looks okay. It is okay. Confirmed now. It's okay. The complement outside has affected the union between B complement and the brackets there. It has taken away the complement on B, and then it sticks outside A complement intersection C complement. Then now it goes inside and takes away the complements. Morgan's law. Okay. Then now we are saying you can also shade it in this way. If you have some time, this is universal A, B, C. Shade A union C first. Shade A union C. This is A union C. Then come back and shade B. Then go back to the pieces that are shaded twice. N part shaded twice becomes our interest now. So you find that here there are two colors. So it is our solution. Then simplify as far as possible. This was 1, 2. P intersection Q minus P complement. This is the same as P intersection Q. Because of the minus here, you write intersection P complement without touching the complement that is outside. Then now you're saying P intersection, take this complement that is outside, take it inside. You have Q complement union P. But look, this is P, this is P. It's intersection, union, different operations. So P becomes the solution. No explanation. Further say, no, this is because of, you just end up saying what you don't know. So just leave it like that.
So can you explain on that property?
There's no property that I've used here. We've just known that it is.
So I mean, like, how have you known, sir? How have you known? Explain.
Okay. This is how I've known. If this is P and this is Q, and I have Q complement union P, that will be, if I do this, Q complement is everything outside Q. This is Q complement. Then union P. This is P. Union means include everything. Then intersection P. So where they are. So now intersection P, we come back and get P. So anywhere I find 3 lines or 2 lines, it's an intersection. So they can see that the whole P has been shaded. That's why I'm saying it's the whole P. If you know of some properties, then you can mention to say, wow, by absorption.
So sir, about if where there is Q complement union P, we put Q complement intersection P, and everything remains intersection.
The fact that you're going to have intersection. If I have P intersection Q complement intersection P, the solution is going to be Q complement intersection P. Intersection P. Because this P is already here. No matter how many times they intersect, it won't affect anything. B, let A be negative 7,3. B be negative 3,3. C be negative 1,6. And R be the universal set. Find each of the following sets. 1. Find A minus B. You know that this is just A intersection B complement. So go for B complement. The universal is R. So B complement is going to be from negative infinity up to negative 3. Because it's included here, you want to include it. Union 3 up to infinity. So get that guy and intersect with A. Negative infinity, negative 3, union 3, positive infinity. So, this is one set. So now you say negative 7 and negative infinity. Of course, negative 7 is bigger than negative infinity. Then negative 3 and 3. Negative 3 is smaller. Then as this guy is ending, this other one is starting at the same 3. And none of those 3 is included. So this becomes a solution. So as you are thinking, you have this. Hello?
Please repeat.
So for you to know how two sets intersect, the key thing is, if you can't visualize by getting the smallest, the biggest, you can go for a number line. You have -7 up to 3. Open, open. Then you're intersecting to -3, open, going to -infinity. Also, from 3, going to infinity. The intersection, nothing is in the open, so you can't pick anything there. So from here, there are 2 lines. And this, that is from -7 up to -3. So it becomes your intersection. Then B intersection C. You start with B intersection C. If B intersection C, B is -3 to +3. Intersection C is -1 to 6. Then you say, okay, between -3 and -1, which one is the biggest? It's -1. Between 3 and 6, which one is the smallest? 3, and it's included. So this is our intersection. Here we want its complement. So its complement is going to be -infinity up to -1. Because it's not included, the complement will include it. Because 3 is included, the complement will open there up to +infinity. So pick that guy, bring it here, and say A is -7 to 3. Intersection, that complement there is from -infinity to -1. Union from 3 to +infinity. So -7, -infinity, -7. 3, -1, -1, and this included. Again, the same thing comes back. This 3 is open, that 3 is open. So you don't go there. This becomes the solution. C1. Simplify and express in the form P plus Q√3. Which question? √27 plus √75 minus √108. Everything divided by 1 minus √3. The question itself gives us a tool to use. Express in the form P plus √3. Get that 3 and use it to break 27, 75, and 108. So you say 27 divided by 3, we get 9. So we're going to write 27 as 9 times 3. 75 divided by 3, you get 25. So I'm going to write it as 25 by 3. 108 divided by 3, you get 36. So you write it as 36 by 3. The good part is that all the numbers that you are getting are perfect square numbers. So when we come here, we say, oh, √27 is no longer 27 now. We'll write it as √9 by 3 plus 75 25 by 3 minus 108, 36 by 3 over 1 minus root 3. The root of 9 is 3. The root of 25 is 5. The root of 86 is 6 over 1 minus root 3. This is equal to 5 plus 3, that's 8. 8 minus 6, that's 2. Root 3 over 1 minus root 3. Then now multiply. We are now rationalizing. Once there's a root in the denominator, go for the denominator and change the sign of that same root. Multiply both on top and down. So on top, 2 root 3 times 1, you get 2 root 3. Plus root 3 times root 3, you get 3. 3 times 2, 6. Over 1 times 1, you get 1. Minus root 3 times root 3, you get 3. So we have 2 root 3 plus 6 over negative 2, which is equal to 2 root 3 over negative 2 plus 6 over negative 2. We'll start with this constant, that is negative 3 minus root 3.
May I please see the previous page?
Then now we go to complex. Express 2 plus 3i.
Sir, can I see the previous slide?
Okay.
Okay, thank you.
So express 2 plus 3i over i minus 1 squared in the form p plus qi. This is complex. These are complex numbers. Nothing changes whether complex or not. If you see a square, multiply that thing inside by itself. So you can do that thing aside, or you can do it just in the question. Say 2 plus 3i over I minus 1, I minus 1. Please don't be confused. The square does not mean you should conjugate. The square means multiply that thing inside by itself. Because you get more excited here, say, oh, it's to conjugate. You forget to square. So I times I, because you have said I is equal to the root of negative 1. So if we square it, we'll be squaring this side, which will mean that I squared is going to be negative 1. So we'll have negative 1, I times negative 1, that is negative I, and negative 1 times I, negative 1 times negative 1, get plus 1. This is giving us 2 plus 3i over negative 2i. Because negative 1 plus 1, at least we know that is 0. So now you get 2 plus 3i. We're now conjugating. So you multiply it by the positive of the down part. Negative 2i you multiply by positive 2i. This is going to be 2 times 2, you get 4i minus I times I, we know it's I squared. I mean, I times I squared. I squared is -1. So you're saying minus 6 over I times I, that is -1. Negative times negative, positive. 2 times 2, 4. So now we have -6 over 4 plus 4i over 4. If we use 2 here, you get -3 over 2. If you use 4 the other side, you get I. Well, I know that when you reach here, you can as well say, if you are used to the system, you can say, oh, since I only have a single thing down here, I'll just multiply by I. And also down, I'll multiply by I. This is going to be 2i minus 3 over I times I, -1. So -1 times -2, you get +2. This is going to be 2i over 2 minus 3 over 2, which is I minus 3 over 2, which is the same as -3 over 2 plus I. So there's nothing to worry about there.
So,
Hello.
I have a question on that.
You can ask.
Oh, I don't know if I can give you like to solve it together. It's similar to what you're doing.
Or a different question.
Yes, sir.
You can say it so that we see if it's fit to your exercise.
It's 2 over. So open bracket 3 minus root 2, close bracket, again minus 1 minus 2 root 3.
Minus?
Close bracket. Right. Yes. Yes, sir.
And then what's the question?
The question is to rationalize the denominator.
So you say, first thing you work out the denominator that you have, 2 over 3 minus root 2 minus 1 plus 2 root 3. This is 2 over 3 minus 1, that is 2, minus root 2 plus 2 root 3. Then you take one at a time. So we have 2 multiplied by 2 minus root 3, minus root 2, meaning this is one number, and then minus 2 root 3. And then down 2 minus root 2 plus 2 root 3. We said this is one number, so we are changing this sign. So we multiply by 2 minus root 2 minus 2 root 3. We are going to have on top, you have 4 minus 2 root 2 minus 4 root 3 over, down you have 2 minus root 2 times 2 minus root 2. So 2 minus root 2 multiplied by 2 minus root 2, and then minus 2 times 2, you get 4, root 3 times root 3, you get 3. Then now we work out the square. So you have 4 minus 2 root 2 minus 4 root 3 over 2 times 2, you get 4 minus 2 root 2 minus 2 root 2. And then root 2 times root 2, we get 2 minus 12. This is the same as 4 minus 2 root 2 minus 4 root 3 over 4 plus 2, that is 6, minus 12, that is negative 6, minus 4 root 2, because this now will be added. And then now multiply by the rational of this guy, plus 4 root 2, negative 6 plus 4 root 2, which is negative 24 plus 16 root 2 plus 12 root 2 plus negative 2 times 4. In fact, it is going to be minus negative 2 times root 4, that is times 4, that is negative 8. Root 2 times root 2, that is 2. So we get negative 16. And then negative 4 times negative 6, that's plus 24 root 3 there. And then negative 4 times 4, that is negative 16. Root 2 times root 3, we get root 6. Remember, you can put these together, just like we are able to separate them. So this whole thing over negative 6 times negative 6, 36, and then negative 4 times 4, that is negative 16, root 2 times root 2, that is 2. So here we get negative 32, 32. So that now we have negative 24 minus 16, that is negative 40. Negative 40 plus 16 plus 12, that is 28 root 2, and then plus 24 root 3 minus 16 root 6, everything over 36 minus 32, that is 4. So you end there.
Sama kasha first year ka.
Patasali lab, I'm behind.
So you let A to be 2 minus root 2 and B to be 2 root 3. So that what you have at this stage is 2 over A plus B. Keeping in mind that B is a surd at the moment. So you come to rationalize by multiplying A minus B, A minus B. This is going to give us 2A minus 2B over A squared minus B squared. Then now go for your A, multiplied by 2. What is 2A? 2A is 2 minus root 2, which is 4 minus 2 root 2. So you bring where there is 2A and put 4 minus 2 root 2, minus go to B and multiply by 2. What is 2B? That is 2 by 2 root 3, which is 4 root 3. So bring 4 root 3 here over A squared. You say that A is this guy, so have it squared. So A squared is going to be 2 minus root 2 multiplied by 2 minus root 2. So you have 4 minus 4 root 2 plus 2. This is 6 minus 4 root 2. So you bring it here, 6 minus 4 root 2, and then minus b squared. Remember I said that b is 2 root 3. Now you're squaring it. So you have 2 root 3 multiplied by 2 root 3. So 2 times 2, that is 4. Root 3 times root 3, that is 3. So you get 12. So you bring 12 here. Then now you have 6 minus 12. You get negative 6 minus 4 root 2. So now at this point, you know that it's just rationalize. So now you can pick it up from there. It means that you have reached which stage? You've reached this stage now. You're just multiplying by the conjugate of negative 6 minus 4 root 2. Well, this is the simplest method. The only method, what we are doing here is just multiplying. And they're just multiplying a plus b times c plus d. This is just expansion. So a times
Thank you very much.
You know, this is AC, this is AD, this is BC, this is BD. As long as you take your time, you can't make a mistake in multiplication. Don't be scared by how many lines are involved in my solution. Let's do as many lines as possible. As long as what you're doing is correct. So multiplication. Okay, so you can log out and log back quickly.